Hello and good evening everyone. Thank you for joining me today in this session. So today in this session we are going to begin pointers. So in this video specifically I am going to introduce to you what pointers are before we begin solving examples on pointers. So before we proceed, we need to understand that whenever we declare a variable, the computer will reserve memory for that variable, and the memory reserved will then store the value of the variable. This is just like me saying int and let me say a. This is a declaration, right? I'm declaring a variable a of type integer. So if I should say a now is equals to what? Is equals to 10. This is what initialization, right? I've initialized the variable to hold the value 10. So what happened in this first case here? In this first case, the computer will reserve memory for this variable a. It will be empty, okay? There is nothing inside the memory. It is just reserved, right? When you do something like this, then that memory that was reserved to you will store the value 10. So this value 10 will be stored in that reserved memory. This is what happened, right? I'm talking about the memory now. This is what happened in the memory. So how do we know the amount of memory that is allocated to our variable? The amount of memory is allocated to our variable depends on the data type of the variable. If it is an integer, the amount of memory will be different. If it is a character, it is different. Float, different. This it depends on the data type. Okay, the amount of memory reserved for your variable depends on what? The data type. Okay, so and also it depends on the operating system in which you are using. So for example now, the data type or the size of character, right? The character data type, the size of character data type is different on a 32-bit machine and on a 64-bit machine. The size of an integer on a 32-bit machine is different with that of a 64-bit machine. Okay, so it depends on what? The size of the characters, sorry, of the data types depends on what? Depends on the type of the machine, right? And also the data type of the character. Sorry, of the variable. Okay, these are what determine the size that is allocated to your variable. So how do we know the size of this variable? Of these data types. We know that we have the character, the float, the integer, a lot of them, right? So we can find out what is the size of these data types on our machine. Okay, so we've talked about this already when we were talking about introduction to C, the C hello world, when we're talking about the compilation process. We've seen how to find the size of a character and also a float and all other data types. So let's try doing this again here. So before that, let me open my terminal. As you can see, I've created a repository mainly called pointers. So I've seeded into the repo. So let me create this test file. All right, so I just want to explain to you the concept. So stdio.h. So here I can just say int main, so void. All right, so assuming I want to find the size of an integer, right? So I can simply say printf, and then what am I printing is a size, right? I'm printing size. So if you are printing the size and the memory from the memory, you need to use a special placeholder, which is what? The LU. This means what? Unsigned long. So anytime you are trying to find the size, you need what? You need to use %LU, okay? Because the size cannot be negative. So that's why it is set to be an unsigned. Do you get it? So here I need to pass what? Let me pass a new line here. So here I will just say size of, you need to call the size of operator, and inside the bracket you pass in the data type in which you want to find the size for. Okay, now this is going to fetch the size of integer for us. So let's see the size of float as well. So %LU, right? So I will just say size of float, right? Then what again? Printf %LU, also this. Then what again? Let's say size of char, right? So size of character. I just want to show you how you can find the size of these different data types on your machine, because like I said, it varies on a 64-bit machine and also a 32-bit machine. So I'm just showing you how to get the information if you are running any of these two operating systems. Okay, so now let's try compiling this and let's see. So if I should say gcc test.c dash or let me call it T. All right, so let's run it. So did you see that we got 441, right? So let me just open the file, cat test.c. So when you look at this, it means the size of integer on my machine, this current machine I'm working on, which is a 64-bit, it is what? It is 4 byte. It is in byte, okay? This size allocated to the memory, to the variables, are in bytes, okay? Not in bits or any other form or any other unit. It is in byte, okay? So this means what? 4 byte of memory. This is also what? 4 byte of memory, and this is what? 1 byte. So on a 64-bit machine, the size of int is 4 byte. On a 64-bit machine, the size of float is 4 byte. On a 64-bit machine, the size of char is 1 byte. So what is going to happen in this case here when I do something like this, int a, right? So the computer will reserve what? Since I'm running a 64-bit machine, from here I've already specified the data type of a, right? So how many bytes of memory will be reserved for a? 4 byte, because int is having what? 4 byte of memory. Okay, from the output we got here, int is having what? 4 byte of memory. So the computer will reserve 4 byte of memory because the variable is supposed to hold an integer and the size of int is 4 byte. Do you get it? So if I should say something like this, char, let's say z. So what is going to happen in this case is the computer will reserve 1 byte of memory. That is on a 64-bit machine. Okay, the computer will reserve what? 1 byte of memory for this variable z, because what? The data type of the variable is char, and the size of char on a 64-bit machine is 1 byte. Do you get it? So this is what happens whenever we declare variable. Okay, so and one thing we need to understand is that these variables here that we are declaring, they are stored in a location in the memory, isn't it? They are stored in a certain location in the memory. So wherever they are stored in the memory, they have their own address. Do you get it? So they have their own address in which you can use that address to locate them. Just like your house now, right? So if you're trying to get a mail delivered to you, you need to put your address. That way you get your mail delivered to your exact location, right? So your address gives the exact location of where you are. Same applies to this. This is exactly what happens in the memory. So when you declare a variable, they are stored in a certain location in the memory. So you can get the address, okay, of that variable. Do you get it? You can get the exact address of that variable, where the variable is stored in the what? In the memory. So how do we do that? Let's say I have something like this. Let me open my test file again. So let me remove this. Assuming I have %d. Yeah, so let me include this hash include stdio.h. Oops, I missed this. So int main void. So this is my test, my main function, right? So all I want to see is that, all I want to show is that how do we get to know the address or where our variables are stored. For example, if I have this variable a, right? I have int a. So how can I get the address that this variable is being declared, is being stored in the memory, right? So I can simply say printf, because I want to print the address. So I need to say printf, and then I need to pass the %p operator. Okay, this means pointer. Okay, since you are trying to print address, take note, we are not printing size here, we are printing address. When you're printing size, you use %lu, right? Because like I explained, the size is what cannot be negative. That's why it is said to be an unsigned long. Do you get it? So you pass in %p since you are trying to print address, right? So after passing %b, what is the variable? This is the variable name a, right? This is the variable in which you want to check the address of. So you need to pass in this special operator which is called the ampersand, and then you pass the variable name a. So in this case, I'm expecting printf to print the address of a. Wherever this variable is stored in the memory, printf is going to print it for me. Okay, so the ampersand operator with the variable in which you want to find the address of is what you need to pass as the argument of your printf. So let's run this. Let's compile GCC. So let's run the compiled file. So did you see that this is the memory? This is the address of the variable a inside my memory. This is how it is stored in the memory. So if I should create another variable here, for instance, let me call it a char, let me call it z. Yeah, So I've declared Z now, right? So I want to print the address of Z in the memory. Where is Z stored in the memory? So I'll just say printf %p, since I'm printing size on a new line, then I will just say and Z here, right? So let's compile again. So did you see something here? Take note of this address. I'm not going to clear it, just take note of this address. So let's compile again. So did you see that this is the address of character, right? Of the character. Is this Z I declared, and this is the address of int A. So as you can see here, this is the address of int. It is entirely different from the first output. So this means that whenever you run the file, whenever you run the program, a new amount of memory is allocated to it. When you are done with the program, then that memory that was initially dedicated to the variable will be released. So that is why whenever you run the program, the memory is being allocated. Whenever you run the program, memory is being allocated. So let me run this program again. So did you see another set of memory is being allocated for both the integer and the character? If I should do this again, did you see that it keeps changing? It keeps changing. So this to show you that these addresses are not permanent. Okay, they are not permanent. They change depending on the call to the program. Okay, so as you can see now, it is stored in this location, but the next call to the program, it is now stored in this location. So this is because if you are done using the program is going to release that memory that it allocates so that other programs can be able to use this. We are going to talk more about this when we begin memory allocations, malloc. Okay, so we are going to talk more about this. But for now, you just need to know how to find the address of these variables. This is simply how to find the address of any variable on your machine. Okay, so now this address here you are seeing here, these are the pointers. Okay, these are what the pointer. A pointer is simply the address of a piece of data in memory. So this is the pointer to what? To a piece of data, which is the variable we declared, but we've not initialized the variable. Okay, if we initialize the variable, this pointer here is going to point to exactly what is stored inside that variable. So for now, we just need to know that a pointer is simply the address of a piece of data in the memory. So now that we've seen what a pointer is, right, we know that it is the address. How can we store this pointer here? Because we need to store the pointers. Because like I said, if you have the address, then that way you can be able to access whatever is stored in that memory, right? So for instance, now if I know your address, I can come to your house, sweep for you, maybe cook for you. I'm sure you don't like my cooking. So you see, if I don't know your address, I cannot do that, right? So this is what we need to. That's why pointers are important here. The address are important because we can use the address to make some changes or to access the information at that particular location. So how do we store these pointers? Pointers are stored in a special variable which are called pointer variable. Let's see how to use this pointer variable. Let me open my test file. So here, let me just remove this. All right, so how do we declare this pointer variable? We said we need to store them in what is called a pointer variable, isn't it? So assuming I have, or the first thing I need to do is when you're trying to declare a pointer variable, you need to pass in the data type, right? You need to pass in the data type of what? Of where the pointer is pointing to. For example, if I say int now and pass in asterisk p, so now I'm creating a pointer which is called p. So definitely by this declaration, my p is not going to hold any value like 10, 5, 4 or something. It is definitely going to hold what? The address. So it cannot hold any value of integer or float or whatsoever. The only value it can hold is an address, because it has already been declared as what? As a pointer. This asterisk here shows that p is a pointer. And this data type simply means that the address that p is going to store is going to point to an integer value. Do you get it? Let me just explain to you this. Now I've declared a pointer and I said it's what? It's a pointer to an integer, right? So if I should declare something like int, let's say a here again. So I want to initialize this variable a, so I can say a is equals to 5. Now I've initialized 5, isn't it? So if I should say p now, since we know that p is only going to store address because it is a pointer, right? So I say p is equals to, how do we get the address of a variable? I've explained that we use the ampersand, and then which variable am I trying to get the address of is a, right? So I pass in a here. So now this will give you a clear explanation of why I used an integer here, because this p here, as you can see, is holding which address of a, and what is stored inside the variable a is an int. So that's why from your declaration of a pointer, you need to tell the pointer what value it's going to hold, the data type of the data it's going to hold. If you pass a character here and you do this same thing, it is not going to work, because your address is pointing toward an integer value instead of a character. Do you get it? So here is set to an int because the variable here is holding an integer, sorry, and p is pointing to this same variable a, which holds an integer. So that's why here has to be what? A pointer to an integer, because it is pointing to an integer value which is stored here. Do you get it? So this is how we store the address. This is not something very complex, believe me. Pointers is not something very complex. Okay, so this is just what this is. Do you get it? So now let's try explaining this in the memory. Let's see how we can represent this in the memory. So this is just a memory layout here, a memory template. This is just used for, just give you a clear example of what a pointer is. So we are going to use this now to give you a clear explanation of what the pointer is. So assuming I have this variable now, if I should say int a like this. So what is going to happen is the computer will just randomly select a part of the memory and allocate how many bytes of memory. This is int 4 byte, right? So assuming the computer selected this 4 byte of memory here, right? So all it's going to do is simply let me see, how can I do this? I'm not that good in this Excel thing. I think it's this, yeah. So here it is just going to declare the variable a. So as you can see now, we have a stored in this variable. And how many bytes did a occupy? 47, 48, 49, 50. So 4 bytes of memory, right? So up to now, in this place, there is nothing in the value. Just take note of this. This is the variable and this is the value portion. So up to now, nothing is stored here. So if I should say a now is equals to 10. Sorry. Now I have initialized the variable 10. Sorry, variable a to hold the value 10. So all what is going to do is we just come to this particular location here. Sorry, how do I do this? I think is it format cells? Wow. I'm not that good in this Excel thing. So let me just do something like this. It's going to hold 10, right? It is going to hold 10. So can I merge it now? Yeah. So as you can see now, this is what will happen in the memory. Initially, after the declaration, it is just going to randomly select a memory location and then give it what? And then allocate 4 bytes depending on the data type. And then when you initialize the value to 10, it is going to hold what? The exact value. So now I have this. Assuming I now create a pointer to an integer, let me call it, actually I'm supposed to do this here before the declaration. So int, let me call it p. I use %p, right? Int p. So this is a pointer to p, right? So what is the size of pointer? Pointers also have their own size in the memory. On a 64-bit machine, they contain 8 bytes of memory. So let's see this. Let me try doing something like this. Printf. So we use %lu since we are printing size, right? So here, this is my pointer, right? P is my pointer. It has already been declared as what? As a pointer. So I'll just pass in p. There is no need for me to add the ampersand here because p is already a pointer, right? So here, I just want to show you the size of pointers on my machine. So if I compile, okay, am I printing? Okay, I need to use size of, sorry. I need to use the size of. Yeah, so I think this is fine now. So let's see. So compile, so let's run it. So did you see it is 8 byte? So the pointer itself is what is 8 byte in the memory. So the memory will randomly select 8 byte for this. So assuming, let me select from 60 here to what? To 60, that would be 67, right? 1, 2, 3, 4, 5, 6, 7, 8, yeah, 8 byte, right? So let me just merge this. So this is going to hold what? The pointer p, isn't it? So this is going to hold p here, because that's the pointer name. So as you can see, it is taking what? 8 byte of memory, right? So if I should do something like this now here, if I should say my p, the pointer in which I created here, if I should say p is equals to what? Ampersand a. So this is holding what? P is now holding the address of a, right? So how can I set P to hold the address of A in this memory template here? So how do we get the address of A first? This is what? A. So the first byte allocated to the memory, or the lowest byte, is what? Is the address of the memory. So as you can see here, we have 47, 48, 49, 50, right? These are the what? The address. This is just a template, like I said. The address are not in this integer format. We've seen that they're in form of hexadecimal values, right? So 47, 48, 49, 50, these are what? The addresses that consist of what? This variable here, A. So the first address is considered the address of this whole variable A. Do you get it? The first address, you can say the first or the lowest, because it is the lowest here, 47, 48, 49, 50. Or simply just say the first address here is what? The address of the first byte is the address of this variable A. So with this 47 now, I can point to this variable A directly. So P is holding the address of A. And what is the address of A? 47. So simply what will happen here is, it will come here, just come here, match. So here it will hold, what is the address? 47. So this is just exactly what is happening in the memory. We declared the variable A, we initialized it with the value 10, we got the address of A, which is what? The first byte, like I said, of the variable, which is 47 in this case, and then we created the pointer, which holds 8 bytes of the memory, and that pointer is pointing to address of A, right? And that pointer is pointing to A. So it only points to A if it knows its address, right? So, and this is the address of A47. So this is what exactly will happen. It will come to this P here and store the address of A. This is what happened in case of pointers. Okay, I believe this is clear, right? So same applies to, let's say I have in a character, pointer to a character, let me call it C here in this case, and then I initialized a character. I created a character called Y, for instance. I declared it. So here, if I should say Y is equals to, let's say, A here, since I'm storing a character, so I need to put it within a single quote. So if I should do something like this and say my pointer, which is C, is equals to address of, where is it? The ampersand address of what? Of Y. So what is going to happen here is, what is this pointer here? This is a pointer to a character, right? So the address of pointer doesn't matter if the pointer is a pointer to a character or a pointer to a float or whatsoever data type. It doesn't matter. As far as it is an 8 byte, it contains 8 byte of the memory. So as far as it is a pointer, it contains 8 byte. So the pointer data type doesn't matter. Okay, so this is what a pointer to a character. So it will randomly select 8 byte as well. So let's say it is here. Let's say from, let's say 24, 26, 27, 28, 29, 30, 31, 32. I think this is 8 byte, right? So I just need to highlight this. I will just merge and center this. So this is what the pointer name is, C, right? So I will just pass in C. 5, 6, 7, 8. Oops, I passed 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I passed 9 instead of 8. So this is going to be 31. All right. Yeah. So merge this, and this is going to hold C. So now this is a pointer. What this particular portion here, the value is supposed to hold an address of a variable. So here I declared a variable of type char, which is Y. So it will just come to here, assuming this case here, it will just store the value Y. As you can see, it's just hold what? A 1 byte of memory. This is because character, the size of char in a 64-bit machine is 1 byte. That's why this is just holding 1 byte, which is just 54. So the next thing that happens is we need to initialize this Y to hold the value of A. So here I will just pass in what? I will just pass in the value A here. So this is what happened. But this A here you are seeing, it's not stored in this format. Okay, it is converted into its ASCII code. It's not stored as A like this. Okay, so we have this now, right? This is the value that Y is holding. So the next thing is, what is the address of Y? This is the only address of Y, which is 54. So C is going to point to this location using its address, right? So I will need to come back here to this C and then store the address, or let me say store the value. Yeah, store the address of Y, which is what? 54. So this C here, as you can see, it holds the address of 54. And where is 54? This is 54. So 54 is pointing to this variable directly. And with this address, you can be able to access this element here. Okay, so now using these pointers, I can change the value of a memory location. I can change the value. anything that is stored inside the variable, I can change it with just its address. So if to say I have this, for this case here, let me just remove this part. Yeah, let me not consider this. Now forget about that. I just want to use the previous example to explain this. So if I have this now, I know that my a is storing the variable 10, right? So I can change this value 10 by just using the pointer. So how do we do that? This is where we use what is called the dereferencing operator. The pointer is p, right? It holds the address. So all I need to do is I need to say asterisk p. So what this is going to do is it will check what is p storing, what address is p holding, address of a. So it will point to the exact data that is stored in address of a. So if I should do something like this now, add asterisk p. What is asterisk p? What is p in fact is 47, right? So and what is stored in that location of 47? Let's look for 47. This is 47 and this is a, right? So if I should do asterisk p, it is pointing to this value directly because 47 is pointing to a. And using that asterisk, you are pointing toward the exact data inside that variable. So if I should say asterisk p here, if I say asterisk p, sorry, if I should say asterisk p is equals to 20 now. So now I have changed the data inside what the variable a, because p is pointing to the what variable a, and now I'm changing whatever a is holding from 10 to 20. So this is going to become something like this. This is what will happen when you use the dereferencing operator. Okay, do you get that? So you just need to use the dereferencing operator if you want to change the value of what a pointer is pointing to. Let's look at this on the terminal. So let's open the test file, the same test file. So if I should, let me just remove this part. So assuming I have this variable int, let me call it n, and also I have a pointer to an integer as well. Let me call it int asterisk, what should I call it? Let me call it p. And then the next thing is I have my n to be equals to, I'm initializing my n now to be equals to 10, for instance, and then I will now say my pointer, which is p, is going to store the address of that n. So I just say and n here, right? So now p is holding what? The address of n, right? And it is pointing to what? The value 10. So if I should print the values now, if I should say printf, right? If I should say printf, let's say value of the variable n here. I want to print the value of the variable, and then I will show you what will happen if we dereference it, right? So the value of n, right? I will use what? Percentage d, since what? N is holding what? An integer, right? I'll use percentage d, and then here I need to pass in what? I need to pass in the variable n. I want to print what n is holding now. Do you get it? And the next thing is I want to print the address of n, right? So I'll just say printf percentage, or let me say address, right, of n, right? I will pass in. How do we get the address? We use percentage p, right, for pointer. Percentage p, let me just add a new line, percentage p, and then here I need to pass what? And percent n. So this way I will get the address of n. So pointer is also holding the address of n. So if I should do something like this and say printf, pointer is holding address, so I will just say value of, that is, the address is the value of p, that is what p is holding, right? So value of p, right? So I will just do something like this. What is p holding? It is a pointer. It's holding an address, right? So I say percentage p /n, and then what here? I just need to pass in the pointer name p. So I'm expecting these two printfs here to print the same thing, because this is printing what? Address of n, right? It's just that in this case it is not stored in any pointer variable, while here we are printing what? The value of p. What is the value of p? It is the address of n. So these two parts here is expected to print the same thing. So let's see what will happen if we run this. So let's run it. So did you see that we got exact same thing here, the same thing here, right? Because the second printf prints what? Print the address of n, and the third printf prints what? The value of n, of p, sorry, and the value of p is holding the address of n. And as you can see here, we got this printed. So now what I want to show here is I want to use the dereferencing operator to change the value of n, right? So if I should do something like this here, if I should say n is pointed to by what? By p, right? P is holding the address of n, and I want to change this value from 10 to p. So I just need to use the dereferencing operator asterisk p, right? Because p is pointing to 10. So asterisk p is equals to what? Let me just make it 20, just like the way I did on the memory template. So if I make it 20 like this, so let me do something like this. Now let me print the value of n. You'll see what will happen. If I should say value of n, so I will just say percentage d, right? Since I'm printing an integer, so I'll just pass in the variable itself, which is n. So let's see what will happen in this case after the dereferencing. From here up to this point, as you can see, the value of n is going to be what? 10. And from this part downwards, whenever I call on n, I'm expecting to see 20, right? So let's compile this. Compile and let's run it. So did you see that the value of n is 20 now? It has been changed from 10 to 20. So this is simply what is called the dereferencing operator. Okay, you use the dereferencing operator to point to exact data that your pointer is pointing to. Do you get it? So this is just a brief introduction of what a pointer is. I've explained the basics and also what you need to know about pointers. So in this video, we are going to talk about arrays and also strings. Okay, so firstly, we need to understand what an array is. An array is simply a contiguous memory areas that hold a number of values of the same data type. So what I'm trying to say here is, assuming you want to store the scores of a student, or let me say the score of 5 students. So instead of you to declare different variables to store information of these 5 students, then you can create an array. And this array is going to store what? The scores of this student. What I'm trying to say is, assuming you have 5 students, you need to say int a, and then you need to initialize the value 5, and then you have another student, let's say int b, you initialize the value, the score, to int c, something like this, up to, let's assume 3 students, right? You have this 3 students here. Let's say this is going to be student 1, student 2, and student 3, right? So as you can see here, for you to store this score, this course of this student, you need to do something like this. So if you have 100 of them, you need to do the same thing. So in this case, as you can see, you are declaring variables, different variables. So you can create an array that is going to store these 3 scores here, or this information here. Okay, so how do we declare an array? To declare an array, the first thing you need to do is you need to specify the data type of what you are going to store in that array. Now in this case, I want to store an integer because I'm storing 5, 2, 3, right? It's an integer, so I just say int. So the next thing is I need to give the variable a name. What is the name of my array? So let me call it score, for instance. So the next thing is you need to give it the size. Do you get it? You need to give the score, the array size. How many elements do you want to store in the array? So in this case, I want to store 3 elements because I'm storing scores of 3 students. So I need to pass 3 here. So now I have declared an array which is called score, and the size of this array is what? Is 3. Do you get it? This is simply declaration of array. So how do I initialize this array? Now, how do I initialize the array? Let me try initializing. I want to, how do I increase the size of this thing? Okay, here. Yeah. So I want to initialize the array to hold these values 5, 2, and 3. So I'll simply say equal to, I will open a curly brace here. So I pass in the first value, which is 5, comma, the second value 2, comma, the third value 3. So now I have an array of how many characters, of how many elements, of 3 elements. Do you get it? This is how to declare an array. So that's simply what an array is. So as you can see here, we are only storing what? Integers in this array. So you cannot store a character in this array because from the array declaration here, you said that it is going to be what? An integer, an array of integers. Do you get it? So let's say I want to store characters. If I say char, that's for characters. So let me just name it, for instance, let me just say A. So how many characters do you want to store here? Assuming I want to store, let's say happy, we have H, A, double P, and Y, 5 characters, right? So I give it 5 here. So all I need to do here is I'll just say it's equals to, then I will open this bracket. Inside a single quote, you add your what? Your H, right? then a comma, right? Then after H you add what? A again, all within what? A single quote, because these are all characters, right? And then P, all within what? A single quote, and then what? Another P within a single quote as well, comma, then the last character Y. So this is what? An array of characters. It contains what? Happy now. Do you get it? These are array of characters. So another way to do this now is I can simply say char, and let me call it B this time. Let me just say, sorry, let me call it B. So let me give it the size is still 5. So I can just simply say equal to, then in double quotes I can pass in HAPPY. This is what? This is a string. Anything enclosed within double quote is called a string. We are going to talk more about string later when we're done talking about arrays. But for now, all you need to understand is what an array is. And you've seen how to declare an array and how to initialize the array, isn't it? So now let's refer to our terminal and let's do something about this array. Okay, so let me create a file. Let me call it tests.c. Test.c. Wow. Yeah, so hash include. All right, so now I want to declare an array to store 5 values. So I can simply say int, and I can say a5 here. I've showed you how to initialize, right? You can simply do something like this: 1, 2, 3, 4, and 5. So this is what initialization of the array. We've declared the array and we've also initialized it. So one thing you need to know is that indexing is how we use to access the element of an array. So when you look at this, this is the first element, right? 1, 2, 3, 4, 5. So in this case, the first element in an array begins with what? Index 0, followed by index 1, followed by index 2, followed by 3, followed by what? 4. This is how they are stored in any array. Okay, this is how they are stored. The first element does not begin with index 1, no. To access it, you don't use you don't say this is in index 1, no, because it is the first element, no. The indexing begins from 0. So you have index 0, index 1, index 2, index 3, index 4. So if you have 5 elements in an array, the last element is going to be at index 4 because it's starting from 0. If you have 20 elements in an array, the last element is going to be at index 19 because when you count from 0 to 19, that's how you get 20. Do you get it? So now let's try something here. Let's say I want to access this element here. This is in index what? Index 0, 1, 2. It is in index 2, right? So I can simply say printf and then pass in what? I'm printing an integer, right? So I'll say %d on a new line, then I'll pass a comma. So how do I access index 2 of this element? First thing I need to do is, what is the array name? The array name is what? Is A, right? So I'll pass in A and then open a square bracket, and inside this bracket I will now pass in the index of the element in which I want to fetch. I want to fetch 3. Which index is 3? 0, 1 to index 2, right? So I just pass in 2 here. So I'm expecting this to print the value 3. And let's test this and see. So if I say gcc test.c, let me give it the name T. Wait. It says, okay, I'm supposed to give a space here, not there, actually. All right, so it has been compiled. So let's run it. So did you see that I got 3? So this is simply indexing. So if I should change this now, instead of 3, let me make this 0. Let's say 0 like this, 0. So I'm expecting this to print what? 1, because 1 is the 0th index, right? So let's compile again and let's run it. So did you see that I got 1 printed? So using the index, that's how you'll be able to get the element at its particular position in an array. Okay, so another way of initializing an array is this. If I like, I can just declare the variable here, sorry, the array. After declaring the array here, I've declared A, right? So here I can simply say A index 0. So now I'm storing the element at index 0. Let's say I want to store 20 at index 0. So this is what will be stored at index 0. And this index 1. So let's say I want to store 25 at index 1, right? So I will go to A index 2, right? And this is going to be, what should be in index 2? Let's say 30, right? So let's say A index 3. So now I have 4 elements here. Let's say 40 here, right? So you can initialize your array like this as well. So as you can see here, I forgot to give it a size here. The size of my array is going to be 4 because it's storing what? 4 element here. Okay, so now let's try printing a index 0. We've already set a index 0 to be 20, right? I'm just trying to show another form of initialization. Okay, so let's compile this again. So GCC, and let's run it. So did you see that I got 20? Because 20 is what is in index 0 of this, right? So if I should make this index 3, let's try printing index 3. Let me try printing index 3 here. All right, so let's see. Compile. So did you see that we got what is exactly in what? In index 3. So what happens in the memory when you do something like this is, or before we move to that, let's just try printing something. All these elements you are seeing here, they are stored in an array format. We've already seen that. And what did we define an array as? We said an array is what? An array in C are contiguous memory areas that hold a number of values of the same data type. Why is it that these arrays are contiguous? Why? So the reason is simply this, or let me not tell you, let's just see it practically why they said array is contiguous. Okay, so I want to print the address of all these elements here. Index 0, where is this stored in the memory? Where is this stored? Where is this stored? Where is this stored as well? So I want to print them, right? So let me try printing this. Before that, let me not print this value. Let me just say I want to print the address, right? So I'll just say %p, right? I'm printing what? I'm printing address, right? I will just say %p and then /n. I would just say ampersand. That's how we get the address. So what is the value? I'm trying to get the address of a index 0, right? So I'll pass in a index 0 here. Do you get it? This how I'm supposed to do this. So let me do for the remaining as well. So this is going to be %p, right? /n ampersand a index 1, right? So this will fetch the address of a index 1. So printf again %p /n ampersand a index 2, right? So printf again, right? %p, right? %p /n, then what? Ampersand a index what? Index 3. So I'm expecting this to print what the address is of this what? Of these arrays here, of the each index of the array here. So now we are going to see why they said array is a contiguous memory location, are stored in contiguous memory location. So let's try compiling this. GCC, and let's run the compiled file. Let me open the file here so that we'll be referencing to it. So when you look at this array has been declared as what? As an integer. It's only going to store integer, right? So an integer in a 64-bit machine holds how many bytes? We've talked about this when we're talking about pointers, right? When we're introducing pointers. So it holds how many bytes in the memory? 4 bytes, right? Integer. So when you look at this, for the first declaration or the first initialization, which is 20, this is the address, right? So take note of this last character here, which is 0 in this case. So when you initialize the second variable, what is in index 1, you know that for this 20 here, it is going to what? Allocate 4 bytes, because you've declared that it is going to hold an integer. So it's going to allocate 4 bytes, right? So after allocating 4 bytes, it started from where? From 0, right? Just look at this last digit here, 0, right? So it means that it will have to go 4 bytes to store the second element, which is 1. So if you count from 0, 1, 2, 3, 4, right? So that's why we are having this stored in memory 4. That is this one here. So this one also, since it is an integer, it will go 4 more bytes again in the memory to store the second one. So that's why after 4 here, when you add 4, you get 8. That's how we got the address of this. So when you add 8, so that you get the address of this, you get what? You are going to get 12, right? So, but in this case, 12 is not represented as 12. It's represented in what? In hex. And C is what? Hexadecimal representation of 12. Okay, so 12 is C in hex. So that's why you are seeing what? C here. So as you can see, the memory, the way they are stored is what is contiguous, because the first one is 0, 4, 8, C here. So it's just giving 4 bytes. This is showing you that, yeah, you are storing an integer, because each int, each declaration, each variable here, each element, it needs how many bytes? 4 bytes. So it will allocate 4 bytes and then move to the next 4 bytes to store the second element, and move to the next 4 bytes to store this, move to the next 4 bytes to store this. So that's why they are in this format. So that's why they are said they are contiguous. Okay, it means they are arranged in order. Okay, they are not, it's not that they will be allocated a space here, then randomly go to another place and allocate a space of the same array. No, it's not going to do that. So that's why arrays are stored in contiguous memory location. So, and we've seen how to get the addresses of this array, right? I believe this is clear. So this is simply array. Okay, so now in brief, let's talk about what a string is. Or before that, let's do something like this. We've seen what array of integers, right? So if I should do something like this now, let me just remove all of this. I just want to show you how we can declare arrays of characters. So here, if I say char, let me call it A, and let's say it's going to take 5 characters as well. So I said we can do something like this. Just declare this. You can just say H, right, comma, A, comma, P. As you can see, I'm enclosing all of them in a single quote because they are what? Characters, right? So Y here. So this is what? Declaration of a of an array of a character. So this is only going to hold character. You cannot store float, you cannot store integer here. So same as the previous example, we can use the index to fetch each element here. So if I should say printf here, since I'm printing a character, what is the placeholder? I'm supposed to use %C for printing characters. So I will pass in a comma. So let's say I want to get this last element, which is Y. So this is index 0, index 1, index 2, 3, and 4. This is index 4, right? So I will say what? A, index 4. So I'm expecting this to print what? The element of what? Or the fourth, the element at the 4th index of A, which is what? Which is Y. So let's compile this. GCC. So let's run it. So as you can see, I got what? I got Y. So even for the case of characters, it is the same thing. As far as it is an array, it is the same way you will need to follow to access each element of the array. So in another way, to declare an array of characters, instead of doing something like this, you can simply do this. Just put this within double quotes. So when you put this within double quotes, you are telling your compiler that, okay, you are going to pass string. So this is what a string is. So here I pass in what? Happy. So simply, this is what a string is. A string is a character, or let me say, is a combination of 2 or more characters. Okay, if you have more than 1 character, it is a string. Assuming I have just H here, this is not a string because we just have 1 character. And if I'm to compile this now, I'm going to get error because I am not supposed to enclose a character within a double quote. I cannot do that. I can only enclose strings within double quotes. So that's why I need to pass in more than 2. I need to pass in 2 or more characters. Do you get it? So same as the way we did initially, this is also in index format. H is what? Is in index 0, A index 1, index 2, index 3, index 4. So any string that you declared in C, it is stored in what? An array format. So assuming you have this happy, let me try to explain this here. You have happy, H A P P Y, right? So you have something like this, H A P P Y. So they are stored in array format as well. So this is index 0, index 1, index 2, sorry, my index 2, index 3, and what? And index 4. Sorry about this, my handwriting. So index 0, 1, 2, 3, and 4. So these are they are also stored in an array format. So strings, just to know this, strings are stored as an array. Okay, so this is simply what an array is. So let's see, how is this thing represented in the memory? So let me open my memory template. So initially we have something like this, right? But before that, let me delete this. So let's assume we have this now. This is what? Score. Let me rename this. Instead of score, let me just use a short name. Let me call it A. No, let me not call it A. Let me call it Z, for instance. So the array name is Z, right? So the moment you do something like this, int Z3, so it means that you are going to store an integer and you're storing 3 integers. So what will happen is this. What is the size of int on a 64-bit machine? It is 4, right? So it will multiply 4 with 3. 4 times 3 is 12. So it will allocate 12 memory. Okay, it will allocate 12 bytes of memory for you. And this is what will happen. So here we have what? Z index 0, right? So for Z index 0, let's assume I'm starting from here, 1, 2, 3, 4, right? So here I can match this. So this is going to be what? Z index 0. Oops, why is it not writing here? Yeah, so Z index 0. So now I have Z index 0 here. So the next 4 byte is going to be what? Is going to be Z index 1, right? Sorry, Z index, Z index 1, right? So now it will move to the next 4 byte again, 1, 2, 3, 4, and it's going to store what? Z index what? Index 2 here in this case, index 2, because we have 0, 1, 2, we have 3 elements, so it's going to start from 0, 1, and 2, isn't it? So now these 4 bytes here, these 4 bytes allocated for each of the index, we are now going to store the elements inside this. So in this case we have what? 5, right? And here we have what? We have 2, isn't it? Imagine. So here it's going to be 2, and then here it's going to be what? Here it's going to be what? It's going to be 3. So I will merge and then I'll paste 3 here. So this is how it is stored. So as you can see, it is stored in contiguous memory location. That's what I'm saying. Initially 4 bytes, and then the next one will be what? Another 4. So for us to get the address of this, it will be what? 4 byte difference. So initially, as you can see, the address of this first index is 60. So for this, it will be 64. That's what I just explained on the terminal. It will be 64. After 64, when you add 4 to it, it's going to be 68. So that's why we are getting this. Okay, so this is how this is stored in the memory. Okay, this is how this is stored in the memory. So I think this is all we need to explain about arrays and also what a string is. Okay, don't worry, we are going to go deep into all these things. This is just an introductory part of this concept, arrays and also string. All right, so let's move on. So before everything here, I've already navigated into my ALX low-level programming, and I've also created the repository in which I need for this project, which is 0x05 pointers, arrays, and strings. And this is it, right? Pointers, arrays, and strings. Also, let me open the content of the file. As you can see, I've created my main.h, my putchar.c function, my readme.md. I'm sure this is not something new, right? The putchar function, you know how to do that. So let me give you an overview of my main.h. So this is my main.h already. This is the prototype of my putchar function, and these 3 prototypes here are the prototypes of the function in which we are going to be writing in this project here, in this particular video, sorry. Okay, all right, so let's move on. Let's begin solving examples. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to b12learn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX complete C programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, small nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also, if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor. Because I've already registered, that's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. So here, the first question here says we should write a function that takes a pointer to an integer as parameter and updates the value it points to 98. So look at this. This is the function pointer. Sorry, this is the function prototype, right? So as you can see, it takes in what? A variable, which is a pointer to an integer. So we are expected to change the value that n is pointing to. Okay, so definitely you know that n is going to hold an address of a variable, right? Because n is a pointer. So whatever n is pointing to, we need to update the value to 98. So just look at this here. Example, the n is 402 here, right? So when it was printed, the first call here, when it was printed, sorry, before changing the value, 402 was printed. But here, when the function is being called, right, and the value of n is printed again, it is printed, it's printed what? 98. So this shows you that what the value of n, or the value that n is pointing to, is what is changed from 402 to 98. So we are to write a function that does that. So let's open the file first. Control C. So vi paste. All right, so we need to include our header file, right? So main.h. I believe this is clear, or let me zoom a bit. Yeah. All right, so what next? Let me document my Betty as I'm going. I think it will be better. So the function name is reset, right? Reset to 98, isn't it? And then int asterisk n. It takes in a pointer. Sorry, I'm not supposed to do this here. All right, so to 98. So what does the function do? Reset n to 98, right? And then what again? It takes in a parameter n, right? So I need to explain that to Betty as well. So at n, let me just say what is n? Pointer to the value to be changed, right? I think this is more descriptive. To be changed. And then what again? The function is returning void, so I need to say return. Here I'll just say void. All right, so here I think this is okay. So let me paste the prototype. No, I mean the prototype. So I'm going to copy this and paste this here. All right, so the first thing we need to do here is this. We are changing the value that n is pointing to. So I've already explained the referencing when we are talking about, when we're introducing pointers. I've talked about the referencing. Okay, so how do we dereference the value that n is pointing to? We simply use the asterisk n. So this is going to directly target whatever n is pointing to, because n is a pointer. It holds an address. So now when you do this, you are saying that, okay, the address that n is pointing to, the value that is in that address, I am targeting it now. So now I want to change it to what? To 98. So I will just say equals to 98. So now I've changed the value. So whatever the value of n is now what? 98. That's simply what the function should do. So let's test this. Let me create the test file, main.c. Right, so let me copy it. Copy the file. Content, paste. So I need to make this modification, hi. All right, so let's run Betty on the file we created, which is what? 0 reset, right? .c. All right, so as you can see, Betty is fine. So let's compile. Copy and paste. Yeah, so it has been compiled as well. So let's run the compiled file. So did you see that we got 402, we got 98? So it means the value of n has been changed, or the value of whatsoever point n is pointing to has been changed. So don't forget to add, commit, and push to your GitHub repository. Then you can run your checks. That's all about this example. So let's move on to the next task. This says we should write a function that swaps the value of two integers. So let's open the file first. We'll explain as we are writing. It will be better this way. So paste. So I need to include what? My main.h, because it contains the prototypes of the function in which I am supposed to write, right? So here I need to document my Betty. I like documenting Betty as I'm going. By looking at this, my function name is what? Swap int, right? Swap int. So I would just say swap two integers. That's what the function should do, right? So what's next after this? Yeah, it takes in two parameters, so I need to explain that to Betty as well. So let me just say value 1 and then at b again, right? So I'll just say, sorry, at b, so I will just call it value 2. Just give it something descriptive, okay? So the function is void, it's returning void, so I need to say void. Right, so let's begin writing the function. So we are to swap two numbers, right? It means that a should be stored in b and the content of b should be stored in a. So there is something we need to do for this, right? I cannot swap the values because all I need to do is I need to say a is equals to b, right? If I say a is equals to b, it means now a is holding the exact content of b. So now that a is holding the exact content of b, it means that we've misplaced the value of a now. We don't have the initial value of a. It's gone because we've already said a is equals to b. So we've overwritten the content of a already, right? So a is gone. So how can we make b to hold the value of a while we don't have the value of a? Because it's gone already, it has been overwritten. So I need to declare a variable in which it will store the value of a. Do you get it? So all I need to do here is I will just say int, let me call it c. So all I'm going to do, I will just say c is equals to what? Asterisk a. So now c is holding the value of a. So the exact value of a and c is not the same thing. Sorry, the content of a and c is the same thing. They are holding the same value. C is just holding a copy of what a is holding, right? So now I can confidently say asterisk a is equals to what? Asterisk b. So it means that now whatever b is holding is now stored in a. So a and b at this position are the same, right? So now I have the content of b inside a, isn't it? So now the next thing is for me to have the content of a inside b, since they are swapping, right? So how can I make how can I make b to hold the initial value of a when a has been overwritten already from this point? So don't forget, I already have this variable that stores the copy of a. So all I need to do here is I will just say asterisk b is equals to c. That's all. This is swapping. So I declared a variable to hold a copy of a, and I said a is equals to b. So the content of a has been overwritten now at this point. That's why I created a copy of it here, right? So that I will be able to store the value of a inside b since we are swapping. That's just what this is. So let's run Betty on this. Betty one swap. That's it. Yeah, so Betty is fine. Let's create the test file one min.c, right? So let's copy the content of the test file, copy, and then paste. All right, so hash I. All right, so let's compile the program, copy, paste. Yeah, so let's run the compiled file. So as you can see, let me run it again. We got what? Initially the value of a is 98, and then the value of b is 42. Now the value of a is 42 and the value of b is 98. So we've successfully done the swapping. So this is simply how to swap values, okay? Please learn how to do the swapping because we are going to need it in a project, okay? In the future, we're going to need it. So I don't expect to take time explaining it again. So please understand the concept of swapping, okay? So don't forget to add, commit, and push your GitHub, and then you can run your checks, okay? So as you can see, I'm working on my Vagrant, so that's why I'm not pushing to GitHub and so on, okay? All right, so let's move on. So this task here says we should write a function that returns the length of a string. So all the function should do is simply to return the length of the string, okay? So if you have, let's say, what is a string first? A string, we said, is a combination of two or more characters, right? If you have a combination of a string, of a character, that's a string. So you are trying a function that will count how many characters are there. Do you get it? So let's open the file first. To learn, let's see. All right, so we need to include our main.h. So document Betty. So what is it? What's the file name? Function name, sorry, underscore strlen. right? So find the length of a string, right? So asterisk after this, it takes in a parameter, so at s, right? So I'll just say parameter or string to be counted, right? String to be counted. So what again? Return, right? So I'll just say return. What should we return? We're supposed to return the length, right, of the string. So I'll just say return length of the string. So I think this is descriptive, right? So here, let me copy this, copy, paste. All right, so how do we do this now? We need to loop over the entire element of s, because s is a string. It contains more than one character, definitely, right? It contains more than one character. So what do we need to do? We need to loop over the entire element of s. Do you get it? So how do we find the length? So I need to loop. For each iteration, I will count. So all I need to do first is I will need to say int I. I'm going to need this for my looping, and then I will declare another variable. Let me call it count, and I'm going to initialize it to equals to 0. So it means that what? This variable is going to start counting from 0. So initially it is set to 0 by default. So it is not counting any character, right? So I will say for I want to begin from 1. Don't forget, our string, I've explained that they are stored in an array format as well, right? Let's say I have H, A, P, P, Y, right? So if I have something like this, this is what? A string. So they are stored in an array format, like this, like this. This is how they are stored in the memory, like this, in this form. And at the end, they have what is called, they have what is called the terminating null byte, which is a /0. Do you get it? So this /0 is simply an indicator that this is the end of a string. So every string, don't exclude anyone, every string must end with this terminating null byte. And this is what? An indicator telling you that this is the end of your string. So whenever you are looping and you encounter this, then it means that you've reached the end of your string. Every string, not every array, please. Every string ends with what? A terminating null byte. This. So take note of this. So this is what index 0, right? Index 1, index 2, index 3, index 4. So here I need to loop. This is what index 5, which contains the terminating null byte. So I want to loop from exactly index 0, right? So I will now say for I equals to 0. So what should be the condition? My variable name is s, right? That stores the string is s. So I just say s. Inside this bracket, I will pass in the variable I. Don't forget, this is indexing, right? This is indexing. I've already explained indexing. We use indexing to get a member of what? Of an array. And we said string are stored in an array format as well. So we can use this on strings as well, right? It's not equals to, I just explained the terminating null byte, which is /0. So what this is saying is that begin your iteration from 0, right? And for this, the iteration should keep running until this condition becomes false. Why do we set this condition? Because I just explained that if you are looping and you encounter this, it means you have reached the end of your string. So as far as the content of at that particular index is not equal to the terminating null byte, then this is when we want our loop to keep running, right? So here I will just say count plus plus. So I will just increment the value of count by 1. Okay, so considering the first iteration, I is 0, so it will check what is at s index 0. So considering our example here, s index 0 is h, right? And then it will check, is it equal to terminating null byte? No, it is not equal to terminating null byte, it is h. So since it is not equal to terminating null byte, it will jump into the loop and it will increment the value of count from 0, we've initialized 0 to what? To 1 now, right? So I will be incremented again. So I is now what? 1. So it will check s index 1. Is it equal to terminating null byte? It will check. No, s index 1, and our example here is a. It is not the terminating null byte. So it will jump into the loop and increment the value of count by 1 again. So we have what? 2 now, right? It will check the same thing again. It will increment I, It will check. I is now what? I is now 2. It will check, is s index 2 equals to terminating null byte? s index 2 is not equal to the terminating number, it is p, so it will increment the value of count to 3. That's how it will keep going until it reaches I is equal to what, this 5, right? So until it reaches s index 5. So s index 5, it will check, is it equal to terminating number? And it will see this, yes, the content at that index is what? Is a terminating null byte. So this part will not be executed. So it will just what? It will just return the value of count. So this way we will have the exact number of characters returned. Okay, so let's run Betty on this first. So Betty, all right, so Betty is happy. Let's create the test file. Copy to main.c, right? So paste. All right, so let's compile. Copy, paste. Yeah, so it has been compiled. So let's run the compiled file. Yeah, so as you can see, we got the exact value, which is 16. Did you see that? So this is how to get the length of a variable, of a string. So if you count this 1, 2, 3, including the space are also characters, okay? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, including the exclamation, 16. But the quotes will not be included. This is just an indicator telling you that this is what a string. So we have 16. So our function is working the way it's supposed to work. Please also learn how to find the length of the string, because we are going to be using it also in most of the project that we'll be having. All right, so here this question says we should write a function that prints a string followed by a new line to std out. The std out simply means your standard output, your screen in this case. Okay, so let's open the file first. Control C, vi, paste. Yeah, so I've already created the Betty documentation because it's taking time for us to always be writing Betty document. So I've already written that before opening the file. All right, so we are trying a function that prints a string followed by a new line. And this is what the string, right? The function is taking what? A string as a parameter. This is it, str. So str is what? Is a string. Let's look at the example. As you can see, str has been declared as a pointer here, and str is holding what? This string here. I do not fear computers, so this is the string. So what the function should do is that whatever is passed to it as a string, it should print it the way it is. That's why we are having this exactly. It is the exact string here that we are having here as well. Okay, so how do we do this? We need a loop, right? We need a loop to loop over the entire str. As you can see, str is what? Is a string, right? It contains a lot of characters here, so we need to loop over them. For each iteration, we print the value. For each iteration, print the character. For each iteration, we print the character, right? So that's what we are going to do. So here, I will just say int I need to declare a variable for my looping. So I will say for I equals to what? Equals to 0, since I'm starting from the first element. And we said characters in string, we said strings are stored what? As an arrays, right? And I've explained that the first element of an array is what? Is of index 0. So that's why I'm starting from 0. It means I'm starting from the first character of the string. So what next again? We need to set a condition to stop it, which is str is the name of the variable, right? So str at index I is not equals to the terminating null byte. So I've explained this. I said the reason why we are doing this is because the terminating null byte is always appended at the end of a string, right? So when you set this condition like this, you're saying that whatever is in ith index of str, as far as it is not the terminating null byte, then jump into the loop and execute whatever the loop is asking you to do. So if I do I plus this, and here, what I'm going to do here is simply what? I'm just going to need putchar here. I'll just say putchar, print the characters. Because I index 0, I is equals to 0, sorry. So str index 0 will be checked. Is it equals to terminating null byte? As you can see here, it is not. I is what? Is what is in str index 0. So it will print the value. So I'll just say putchar here, and then I'll say str at that index, right? Whatever it is. So here, it will print what? I. So I will increment, right? So it will check str index 1 now. Since I is now 1, it has been incremented from 0 to 1. Is what is what is in str index 1? Is it equals to terminating null byte? What is in index 1? Our index 1 is a space here, so it is not a terminating null byte, right? So put char will print it. It will jump into the loop and print it. It will increment. That's how it will go until it reaches the terminating null byte. And the terminating null byte is always appended after the last character of a string. You can't see it actually. It's just there. You cannot see it. It is there. Okay? So that's how to loop over the entire set of string. So the next thing I need to do is what? I need to say put char for a new line, right? So after printing it, jump to a new line. All right. So let's run Betty. So 3 puts .c. Yeah. So let's create the test file, which is 3main.c. So copy this, copy and paste. All right. So here I need to, yeah. All right. So let's compile the program. Compile, paste. Whoa, I missed something. Implicit dict. Okay, I think I've not included the prototype in my main.h. Yeah. So let me go to my main.h. Main.h. Yeah, I've not done that. That's why I'm getting implicit declaration of the function. So let me paste this here. All right, so let's move on. So let's compile again. Yeah, so as you can see now it has been compiled. So let's run it. Yeah, so as you can see we got the exact same output here. I do not fear computers, I fear the lack of them. Isaac Asimov. So this is the exact content in which we are getting here. Okay, so this is simply how to loop and print an entire string. Okay, so now let's move on to the next task. Don't forget add, commit and push to your GitHub repository and then run your checks. So this says we should write a function that print a string in reverse. So in the previous example we've seen, we printed the string, right? But not in reverse. But in this case, we are asked to print the string in reverse, right? So let's see how to do this. We need to print the string in reverse, right? So copy this, so vi, paste, file name. So for this one as well, I've already created the Betty document so that I will not be wasting time on that. Okay, so now we have a string. This is the string that is passed to the function. I do not fear the lack of them. So when the function is being called and the string is passed as parameter to the function, as you can see, it is printed in reverse, right? So let me explain something to you here. I want to print the string in reverse, right? So if I have h a p p y like this, right, and I have the terminating null byte here. So I have explained that this is how they are stored in an array format in the memory, right? They are stored like this in the memory. So this is what index 0, right? Index 1, index 2, 3, 4, and then 5, right? This is index 1, 2, 3, 0, 1, 2, 3, 4, and 5. So I want to start printing from this y now, right, which is the last character. I want to start printing from y because I'm printing in reverse. So if it is a reverse, so I need to start printing from this. So what I need to do is simply this. For me to know the index of my last character, I need to what? I need to find the length of the string entirely. So what is the length of this string? 1, 2, 3, 4, 5. Don't count including the null byte, because when you're trying to find the length of a string, the null byte is not part of it. The null byte terminator is not. Okay, so it will stop at y. So how many characters do we have here? We have 5. This is the length of the string, 5, right? So 5 is the length of the string. So, and where do I need to start counting from? I need to start counting from what? From y, right? And the length of the string is 5. So it means that my length of the string minus 1 will give me the exact position of where I need to start my loop from. So 5 is what? The length is 5. Right? So it's going to be 5 minus 1, which is 4, right? So what is in index 4? Index 4 is holding the last character of the string. Do you get it? So if I have, let's say, 20 characters, you know that it's going to end with a terminating null byte, right? Which makes it 21. So the length of the character is what? Is 20, right? The length of the character is 20. So 20 minus 1 is going to be 19. So I've already explained this, that if you are to target the last element or the last character of a string, you need to what? Minus 1 from the length of it, because it is starting from what? Index 0. Just like in this case, we have 5, the length of string is 5, but we need to minus 1 for us to have access to the last element. because it's starting from 0. Okay, so that's what we need to do. We need to start our loop from where? From the last character here. And how do we start from the last character? We need to find the length of the string entirely, and then we minus 1. So as we minus 1, instead of us to be incrementing our loop with I++, we will be using what? I minus minus. Why will we be using I minus minus? Because we are going backwards. Okay, PPAH, we are going backwards. If you say plus plus, it will move to the next element after the y, but we are targeting the elements before the y now. I'm just trying to give you an insight on how we can solve the problem. Okay, so the first thing I need to do is I will declare a variable, since we said we are going to what? We are going to need a variable for count, right? So I'll just say int, I will call it count, I will initialize it to 0. Right? So now the next thing I need to do is what? I need to loop to find the length of s, which is this character here, the set of string passed here. So I equals to 0. So what should be the condition? S index I. If you are to loop over an entire string, this is the condition you are going to use. Determinating null byte, then I plus plus. I'm sure you are familiar with this now. I'm just trying to tell you that I'm starting from the first element, and then what? As far as this condition is true, right? As far as this condition is not true, sorry, go into the loop, and then I plus plus is just the increment. Then what should happen if the condition is true? I want to increment the value of count. So this way I will have count holding the exact number of variables. So the next thing I need to do is I need to loop from where? From the last element of s, right? So I'll just say for. So what should be my condition here? What should be my condition? Sorry, initialization. I'm starting from where? From count minus 1, isn't it? I'm starting from count minus 1. So I will say for I equals to count minus 1. So now you are starting from what? Count minus 1, which is what? This exact last element here. And I've explained why we are having count minus 1. Right? So the next thing is what? What should be the condition now? Since we are not moving in this direction now, you know that we cannot use the terminating null byte as what? As a terminating condition, as the condition that will start the loop. So we are moving like this in this direction. So what should we do? We just need to set our value of I should always be greater than or equals to 0. It cannot be less than 0, because this is the last element, right? And the last index we want to stop our loop is what? Index 0. So I will just set a loop, sorry, I will just set a condition and say I must be greater than or equals to 0. So this way it will only stop when it reaches index 0. Do you get it? So the next thing is what? I will just need to say I minus minus. Why are we saying minus minus? Because we are printing in reverse. Okay, so here the next thing I need to do is I will just say put char. Right, as far as this condition here, I is greater than or equals to 0 is true, then I want to print s at that particular index. So this way I will have it printed in what? In reverse. Okay, so here I will pass in put char to print what? A new line. So /n. So this is simply how the function is supposed to look like. So let's run Betty on this. Betty for print.c. Oops, trailing white space line 18. So let's see. Set number line 18. Okay. So I think that's the last put char I wrote. Yeah, there is a space after the semicolon. So yeah, Betty is happy. So let's compile it and let's see if we are going to get this string printed in reverse. So paste. What it says? Okay, we've not copied the main.c file. So let me copy it. Vi main, sorry, for main.c. Main.c. So paste this. Alright, so #i. Alright, so let's compile now. GCC. Good. So let's run the compiled file. Yeah. So as you can see, we got the string printed in reverse. Did you see that? This is how it was passed. I do not fear computers, I fear the lack of them, by Isaac Asimov. But now as you can see, it is printed from the last character to the first character. Same as this output here. Okay, so this is simply how you can loop over over string. They are just trying to make sure you guys understand and learn how to loop over a set of string, because you'll be needing it a lot in C programming. Okay, so in this task here, we are told to write a function that reverses a string. In the previous task, we wrote a function to print the string in reverse, but in this case, it reverses the string. Okay, we are not printing, it reverses the string. So how do we begin writing this? So one thing I need to show you here is this. Let's say we have h, I am a string, let me use this, h, a, right, p, another p here, or let me do this, another p here, and then y here, right? We have this. So how can I make this to be printed in reverse? So it means that I need to start printing from yppah. That's how we did in the previous task, right? But in this task, we are not going to do the same thing. Okay, we are not going to do the same thing. We are going to adopt the method of swapping. This is index 0, right? This is index 1. Sorry, my screen is misbehaving. Index 2, index 3, and index 4. Right? Let me make this, yeah, 0, 1, 2, 3, and 4. Right? So I want to swap this. If I do something like this, like I said, arrays or strings are stored in array formats. So not like this. So I need to do something like this. Yeah. Okay, so here I need to provide an extra space for the terminating null byte. So this is how they are stored in the memory, right? So I want to print this in reverse. So it means what? It means that whatever is in index 0 will be replaced with whatever is in index 4. So here, whatever is index 0, which is h, will be swapped with whatever is in index 4, which is y. So I'm going to swap the values, right? So whatever is in this index is going to be swapped with what? With this. So whatever is in the second index, whatever is the second character, which is in index 1, will be replaced with what? With the character, which with the second to the last character, right? And this one being in the middle will remain the way it is, right? So it means I need to do swapping here. Okay, whatever is in index 0 should be replaced with whatever is in the last, whatever the last character is. Whatever is in index 1, which is the second character, should be replaced with whatever is the second to the last character. So at the end, I'm going to have what? Y at index 0. I'm going to have what? P at index 1. And I'm going to have this P, since it's not swapped with any value, at index 2, which is P. And then I'm going to have AH, something like this. Right? So when you look at this, I cannot be able to do this swapping until I know the length of the string. Right? Until I know the length of the string, because I need to know the length of the string so that I'll be able to stop my looping. Secondly, what I need to tell you here is that I don't need to loop from the beginning up to the end of the string. Why? Just look at this. Because I only need to loop halfway. Sorry, I need to loop just halfway. Because for the first iteration here, I'm replacing what? Two values. I'm replacing the content of index 0 with the content of index 4, and I'm replacing the content at index 4 with the content of index 0. Do you get it? So I need to do this loop. This loop is a must, and I need to do this loop as well. So as you can see here, I just need two loops to do my swapping, right? I just need to loop over H and A and replace them with P and Y. So I just need two loops here to do my swapping. So there is no need for me to loop from from index 0 up to the last index. No, I just need to loop halfway. Do you get it? So I need to find the length of the string and divide it by 2. So that way I'll be able to set the condition of my looping. Do you get it? I repeat, I'm not looping up to the end of the string, and this is the reason. Because for each loop, I'm replacing the value at that index with the value at the supposed index. Okay? So I just believe this is clear. So I'm not looping up to the end. I'm looping just halfway, half of the string. So here I'm going to loop just over H and A. That's all. Do you get it? I'm just going to loop over H and A. So here I have 5 characters, right? So if I say 5 divided by 2, I mean I'm using this divisor operator, not modulo. 5 divided by 2 will give me what? Will give me 2. Isn't it? 5 divided by 2 will give me 2. Right? It will not show the remainder. It will give me 2. So what is in index 2? Index 2 is this. Right? This is what is in index 2. So all I need to do here is what? I need to divide by 2, and this is where I need to stop my looping. Do you get it? I just need to set that. I'm not going to include this 2 here. I'll just say less than 2. So 0 and 1 will be looped only. Only 0 and 1 will be looped. Since this one, it has no partner to loop with, so there is no need for me including that. So one thing you need to know is that you must find the length of the string. You divide the length of the string by 2. That will give you the condition in which your loop will keep running, or the condition that your loop will stop running. Okay, so let's see. The first thing we need to do, like I said, is we need to find the length of the string, right? So copy and paste here. So here I already have my Betty documentation. So what we need to do next is this. We need to find the length of string, right? So I just say int I. I'm going to use this for the looping. Int count, which is equals to 0. I'm initializing the variable count, which I'm going to use for counting. So I will say for I equals to 0. Here I'm trying to find the length of the string. Okay, so I need to loop over everything, right? So s, which is the variable here, the pointer, s index I is not equals to the terminating no byte, then I plus plus, right? So here I'll just say count plus plus. So now this variable count will keep track of the number of characters in s. So the next thing is I need to begin the loop for my printing, how I need to print. So I've already set a condition for that. Sorry, I've explained how we can set the condition. So I'm starting from where? Index 0, right? Just look at this. I'm starting from index 0, right? So I'll say I equals to what? Equals to 0. And what is the condition? I said we are only looping halfway, right? And we need to say what? We need to say the length of the string entirely divided by 2. That way that's how we'll be able to get the halfway of the string, right? So all I need to do here is I has to be less than count, right? Count divided by 2. So I believe this is clear now. So what is the value of count? In this case, the value of count is 5, isn't it? 5 divided by 2 is what? Is 2. When you use this divisor operator, right, it is 2. So this is 2. And we are not going to include this 2 here because it doesn't have any partner to swap with. So that's why I said less than 2. So it's only going to loop 0 and 1. Okay, so and then what? And then I'll say I plus plus. So inside this loop, all I need to do now is what? Is do the swapping, because I said we are going to swap, right? We are going to swap. So how do we do the swapping? If you can remember, in the first task here, or the second task of this project, when we are to do swapping, we declared an extra variable, right? So let me declare another variable here. Let me call it G here instead. So we declare another variable J, and this G is going to hold what? The content, right? The content of one of the elements in which you want to swap with. So here I don't think it's supposed to be int. It's supposed to be char actually, because it's a pointer to a character. So char G, right? Yeah. So we are going to store a character inside. So that's why I declared it as a character. So J is now equals to what? S, right, at index I. So whatever is in index I, I'm going to what? Store it in S. So the next thing is what? I need to replace what is in index I here with the what? With the corresponding element. So here, taking this into consideration, I have this 0, right? Index 0. So I'm storing whatever element of 0 is, right? That's why I said S index I. As the value of I changes, the index will change, right? So if I have this S index 0 stored in the variable J, so the next thing I need to do is say whatever is in this index 0 should store what? This last variable here, this last character, sorry. So all I need to do here, I'll just say S index I is now equals to what? Now I will set this to hold the last character. So how do we get the last character of a string? So it's simply what? Count minus 1. Right? So count minus 1 will give us what? The index of the last character. Looking at this, the number of element here is what? Is 5. So 5 minus 1 is 4. And this will give us what? 4, which is the last element. So if I say count S, what? Count minus 1 here. This will target what? The last element. So this is just saying that whatever is in index I, copy the last element and paste it in that position. So it will overwrite whatever is in index 0, considering the first iteration, right? So, but when you look at this, there is no value of I here. So this will will not be changing, right? So as I increases, this will not increase. What I'm trying to say is, if now our I becomes 1, right? So we are trying to what? Store the content of this. We are trying to override the content of 1 with what? With the content of P here. With the content of 3 here. Because these are what? The two values that will be swapped. But when you look at the example here, the code here, we are just targeting the last character. So it will keep on targeting this last character 4 because we are still using count minus 1 and the count is still 5 minus 1, which is 4. So it will keep counting this for each iteration. It will keep targeting this. So how do we get this to move to the next index? Move to the index before it, move to the index before it, move to 3, move to 2. How do we get to do that? So here we need to say what? Minus I here. So it means that if I is 0, it will what? It will replace whatever is in index 0 with count minus 1, which is 4, minus I. I is 0 already, so it still remains 4. So it's going to replace H with what? With Y. Index 0 with what? With 4. So if I moves to 1, what do we have now? We have A here. So it will now replace whatever is in index 1 with what? Count minus 1, which is what? Which is 4 minus I. The value of I has been incremented to 1, don't forget. So it's going to be 5 minus 1, which is 4 minus I, which is 1, right? So minus 1, which is going to be what? 3. So this way we have this index. So the element at this position will be swapped with this position. So as you can see now, it is changing. As the value of I is changing, the last element we are targeting is also changing, right? So here I will now say what? I have successfully swapped what? The first index, the first element with the last element. So the next thing I need to do is to store the first element with this. What I did above here, just look at this, I've explained this. What I did above here is whatever is in index 0, I'm considering the first iteration, replace it with the last element. Do you get it? So now index 0 and the last element is the same. So now the next thing I need to do is I need to replace the last element with what index 0 is holding. That is why I declared the variable j and store whatever is in index 0 in this variable j. So all I need to do now is I just need to say s count minus 1, right, minus I is equals to what? Is equals to j. So I've done the swapping. Please refer to the video we just made on swapping, okay, or understand all these things, okay? So all you need to understand here is just how to get the last element, which is what I just explained here. It's simply count minus 1. That's how you get the last element. But if you want to be decrementing, if you want to be moving backward, you need to minus I again, so that it will be changing. The index will be changing. Okay, as value of I is increasing, the index is also changing. Okay, so that's all we need to do here. So the next thing we need to do is just add a put char. Did they request a new line? Okay, just said reverse a string. So I think it is okay like this. Let's just test. So I'll just say Betty here 5 rev string.c. all right, so as you can see, Betty is happy. So let's let's copy the test file main.c. so paste this here. All right, so here I need to say hash I. All right, so the next thing is to compile the program, and let's see if our program is going to work. So copy, paste. Wow, it says char j. So what does this mean? Unused variable j. No, we did. What I'm supposed to do here is, instead of me to declare it here, I just need to do this inside the for loop. Yeah, since it is used inside the for loop, so I will just say char j here. All right, so I think this should be fine. So let's run Betty on this. What's the file name? 5. Yeah, so Betty is fine. So let's compile the program. Yeah, so as you can see now, it has been compiled, right? So .5. So as you can see, we got my school, and then we got it printed in reverse again. So this is simply how you can reverse a string, right? A function to reverse a string. All right, so don't forget to add, commit, and push to a GitHub repository, and then you can run your checks. So this task here says we should write a function that prints every other character of a string, starting with the first character, followed by a new line. So this is the prototype to the function. I've already pasted the prototype in my main.h just to avoid time wastage. So this prototype is already in my header file. So let's look at the output here. If you look at this, this is what was passed to the function when it is called 0 up to 9, right? And this is where the function is being called, and this is what the parameter. And this str stores this what? This content here. So, but when the program is run, look at the output here, 0, 2, 4, 6, 8. So if you notice something here, only the even numbers are printed out of what? All of these numbers here. So it means that the odd numbers are excluded. 0 is an even number, and from the question it says starting with the first character. So the first character is 0, right? So 0 is even, isn't it? So this gives us a clue on what we are going to print. Are we printing even numbers or odd numbers? Had it mean this says starting with the second character, so I know I'm printing from this, right? So if I'm printing from 1, then I only need to print the odd numbers, because I need to skip 2, print 3, skip 4, print 5. So but in this case you are told to start from 0, so I only need to print the even numbers now, just like how it is here in the output, right? So the first thing we need to do is open the file. Let me open the file. So vi paste. All right, so I have my Betty documented already. All I need to do here is simply do something like this. Like I said, we are only interested in printing what? The even numbers, right? We are only interested in printing the even numbers. So I need to loop over the entire str, which is this. So as I'm looping, I need to check if it is an even number or not. So I need to declare the variable I, or any variable which you can use for your looping. So I will say for I equals to 0. I'm sure by now you must have been familiar on how to loop over a set of string, and then not equals to the terminating or byte I plus plus, right? So I have this. So the next thing I need to do is inside this for loop, I need to set a condition to check if the value of I is an even number. So it means that the index in which I'm checking has to be an even index. If the index is an odd index, then I don't need to print it, because just look at this, we are only printing what? The even ones here, right? So I need to see if my I modulo 2 is equals to 0. This is how we check for even number, right? We all know what this modulo operator does. It returns the remainder. So if the remainder after dividing by 2 is 0, then it means it is what? An even number. And what should we do in this case? So in this case, all I need to do here is I'll just call my putchar. I'll just say putchar print str at that particular index, because the index is an even number. So that way I'll be able to get every other character. I will not get the odd numbered characters. What they mean by every order is simply print the first one, skip the second one, print the third one, skip the fourth one. That's how that's what every other character means. So here I will just call on putchar, and then I will pass in what? A /n for my new line. So this is all we need to do about this. So let's run Betty here. So Betty 6 puts.c. Yeah, so Betty is fine. So I've already created the main.c file. Did you see that? I already have the main.c file here. So you can copy it and paste it in the appropriate file. So here, all I need to do now is simply compile the program. So I will need to copy this, and then I will paste here. So as you can see, it has been compiled, right? So let's run the compiled file and see. So as you can see, we got 02468. So we got what? Every other character. We got only the even characters printed. So this is just what we need to do about this function. So don't forget to add, commit, and push to your GitHub repository, then you can run your checks. So let's move on to the next task. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to bitweblearn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX Complete C Programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, more nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also, if you have a course that you want to sell on this website, you can register as an instructor. Simply come here, and then you can click on instructor registration. You can register as an instructor because I've already registered. That's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. So this task here says we should write a function that prints half of a string followed by a new line. So this is the prototype. I already have it in my main.h. So the function should print the second half of the string. If the number of characters is odd, the function should print the last n characters of the string, where n is this. Okay, so all what this question is asking us to do is this. When you look at this, we have from 0 to 9, right, passed to the function. So we're expected to print only half of this, and not just the first half, but the last half or the second half. So if you divide this by 2, what are you going to get? 0, 1, 2, 3, 4, right? So it means you are to start printing from 5, 6, 7, 8, 9. Right? That's just what this question is asking us to do. Divide it by 2 and print the second half. Do you get it? So how do we do this now? Let's copy the file name here. Let's open the file. Paste. So I already have my Betty documented. So if I should do something like this here, right? So to do this, we definitely need to know the length of our string, right? Because we cannot divide the string without knowing the length. Because we are dividing the string, we are dividing it by 2. So we need to know the length before we can divide it by 2. Assuming the length is 10, so we need to say 10 divided by 2. So we need to find the length. So the first thing I'm going to do is I'll just say int I here, right? And here when you look at this, they said what? The function should print the last n character. So let me just declare a character. It's not necessary that the character name must be n, okay? I'm just trying to use n, okay? So int n, so I'll just say for I equals to 0. You must have been familiar with how to find the length of a string, or to loop over a set of string or the entire string, right? So I plus plus. So here I will just say count. I forgot to declare the variable count. So here I can say count, and I can still initialize it equals to 0 in one line. Declaration and initialization is allowed. All right, so the next thing we need to do here is we are told that n is equals to this, right? The length of string minus 1 divided by 2. So I'll just say n is equals to, what is the length of the string? Count is responsible for holding the length of my string, isn't it? So I'll just say count here minus 1, right? All divided by 2. So this will get what? The half of the string. So let me show you this here. Assuming we have h a p p y here, right? Assume we have something like this. So it says that n is the length of string minus 1. So what is the length of the string here? We have 5. So it is going to be what? 5 minus 1, isn't it? Let's look at the question again. So minus 1 and then divide by 2, isn't it? So 5 minus 1 is simply what? 4, right? 4 divided by 2 is what? Is 2. So this will give us what? 2. So let's see how we can write this. This is it. So now the next thing we need to do is to loop, right? So I will say for I, where am I starting my looping from? I'm starting my looping from n here, right? N plus 1. Why is it n plus 1? Because I'm supposed to print from this part here up to the end of the string. Do you get it? I'm supposed to print from this part of the end of the string. Let's look at the question once again. It says the function should print the second half of the string, right? The second half of the string. If the number of characters is odd, the function should print the last n characters. The last n characters of the string. So here, what is the value of n? Our n here, where we've seen that the n is simply count minus 1 over 2. So what is the value of count here? 1, 2, 3, 4, 5, right? 5 characters here. Minus 1 is 4, isn't it? 4 divided by 2 is what? 4 divided by 2 is 2. So it means that we are printing this last 2 digits here. Do you get it? We are printing this last 2 digit here. Assuming we have another y here, right? So our count is what? 6. 6 minus 1 is 5, isn't it? 6 minus 1 is 5. So 5 divided by 2 is still 2. So we are still printing what? We are now printing what? Just this y here. Do you get it? That's just what the question says we should do. So here, that's why I said plus 1 here. So I'm starting from n plus 1. So what should be the condition? I is going to be what? Sorry, the condition is going to be str index I not equals to the terminating null byte. Then here, I can say I plus plus. Okay? So what's the next thing we need to do? So inside this for loop, I can now call my putchar. I'll just say putchar, print whatever is at that index of str I here. So the next thing is what? Print a new line. So putchar this /n. So now we have the complete code. So this code here is supposed to print the second half of a string. Okay, I believe this is clear. So let's run Betty on this. So Betty 7 puts half.c. Okay, trailing white space on line 19. Wow, why? Okay, it's in caps. Set number line 19. Okay, line 19. I left a space. Okay, yeah, I do. So let's run Betty again. All right, so let's create the test file, which is 7main.c. So copy the code and paste here. So here I need to add #i. All right, so let's copy the compilation command and let's compile and see if we will get the exact output. So it has been compiled. So let's run it. So as you can see, we got 56789. 56789. So it means the code works the way it's supposed to work. Okay, so don't forget to add, commit, and push to a GitHub repository, and then you can run your checks. So now let's move on to the next task. So this task here says we should write a function that prints n elements of an array of integers followed by a new line. So we are to print n elements of an array of integers. So this means that there is an array already, and this array contains integer values. So we are only interested in printing n element of that array, not all the elements of the array. So assuming n is 5, just look at the parameter here passed to the function. Assuming n is 5, so it means you are only going to print 5 elements of the array. If n is 2, you are only interested in printing 2 elements of the array. So you are not printing everything of the array. Okay, you are printing n elements. So let's open the file. So vi. Yeah, so I already have this documented as well to avoid time wastage. So here, what do we need to do first? So the first thing we need to do here is we need to loop, right? We are going to loop over what? The entire A here. This A here you are seeing is a pointer to the array, right? It is a pointer to the array. So we are going to loop from 0 to the value that is less than n. That is if you are starting from 0. So all I'm trying to say is I need to loop and say int I. So I need to say for, I'm starting from 0, I equals to 0 from the first element of the array, right? So what should be the condition here? I less than n. Why is it less than n? Because if you pass n to be 5, count from 0 to 4, that's when you will get 5. So if you include n, it's going to be 6. So you are not going to get the exact output, okay? So then here I will just say I, what? I plus plus. So now I have this follow. So the next thing I need to do here is simply this. I need to print the value at that index or at each index, right? So I need to say here, as you can see, they said we are allowed to use printf. So I can simply say printf. Since I'm printing digit, it says what? Array of integers. So we are printing an integer. So I use %d, right? And here, how do we print array of integers? I've already explained this, right? Sorry, how do we print the element of an array, right? So what's the array name? Here the array name is A. This is the pointer to the array. So A index what? Index I. So this way I will get A index I printed, whatever is in that index. So the next thing is, they said the number should be displayed in the same order as they are stored, and they must be separated by comma followed by a space, right? So we are to separate them by comma followed by a space, but notice the last element here. There is no comma and the space after the last element. So we need to take care of this so that our comma and the space will not appear after the last element here, right? So I need to set a condition. So what is the last element here? This is simply n minus 1 element, right? This is simply n minus 1 element. That's how we'll be able to target this remaining part here, right? That's how we'll target this remaining part here, isn't it? I need to say if I, is less than n minus 1. N minus 1. So what is the value of n? Whatever the value of n is, as far as the I is 1 less than the value of n, it means that just this part here is excluding the last part here, right? Excluding the last part. So only if this condition is true, then I want to print what? Comma and the space. So I'll just say printf comma and space here. Do you get it? So it will first print the element and then it will check. If I is less than n minus 1, then definitely it knows that it is not going to the last character, right? The next element it will encounter is not the last element, so it will print comma and the space. If this condition is false, so it means that's the last element, so this part here will not be executed. So here I will just call my printf and pass in /n for a new line. So this should work now. So let's run Betty on this. So Betty, this is task 8, right? So all right, so it has been Betty is happy. So let's create the test file, copy this, so vi 8 main.c, right? So paste. So here I need to say #i, right? All right, so let's compile now. Where is it? Yeah, GCC. So paste this. Oh, it says printf. Yeah, so in this case we are supposed to include our stdio.h header file, right? So to be on the safer side, instead of you to be always including it on the file you are writing, you can just do that on your in your main.h file. So since you are already including your main.h every time, so whenever you include it, it will include the stdio.h also. So stdio.h. Okay, so this is a good practice. So your stdio.h should always be, or should also be, inside your main.h to avoid such problems here. So let's compile again. So as you can see, it has been compiled. So let's run the compiled file. Yeah, so as you can see, we got what? 98, 402, minus 98, 298, and minus 1024. As you can see, we don't have the comma and the space at the end of the last character. Last element. So don't forget to add, commit, and push to a GitHub, and then you can run your checks. So it says what? This is a function prototype. Write a function that copies the string pointed to by src, including the terminating null byte, to the buffer pointed to by dest. Return value the pointer to dest. It says for information, the standard library provides similar function strcpy. This is a standard function that is used to perform the same operation of the same function as the function we are supposed to write in this particular project. Okay, so you can just command this down on your terminal, or you can learn more about the strcpy function. So it says we are trying a function that copies the string pointed to by src. So we are going to copy whatever string src is pointing to what? To dest. So this simply means the source, and this simply means the destination. So we are copying whatever is in source to where? To destination here. So let's open the file. So vi paste this. Yeah, so it has been documented already. So what we need to do here is this. My function prototype is already inside my main.h. Okay, so I've already pasted it there. All right, so what do we need to do first? We are going to need a loop, right? We are going to loop over the entire element of src. Let me show you this here. So assuming we have something like this, let's say I have let's say d. Let me just use something short, d, right? And this is what in the source string, or let me do it again. Let me say we have src, right? This is a pointer, right? This is pointing to this string here, d. So d, like this. So we are copying whatever is in d into what? Into dest. So this is index 0. We know that strings are stored as what? Arrays. So index 1, this is index 0, index 1, and what? An index 2 here. and we all know that a terminating null byte will be appended at the end, right? There is a terminating null byte. So we're asked to copy the entire element of source, whatever string source is pointing to where? To dest. So I have something like this, dest, right? Forgive my handwriting. So dest is equals to what? Whatever is in index 0 of source should be at index 0 of dest. So this is going to hold what? D. What is in index 1? So whatever is in index 1 of source should be at index 1 of where? Of dest. So this is going to be what? A here. So the index 2 should be what? Index 2. So this is going to be what? Y here. The terminating null byte here is going to be what? 3 here. Right? So we are asked to copy everything. So when you look at this, we are going to loop, right? We are going to iterate over the entire source here, right? Each element of source. So we are going to loop over it, and for each iteration, we are going to store it in dest. So if we iterate over index 0, we are going to store whatever is in index 0 of source to index 0 of dest. Whatever is in index 1 of source, we are going to store it in index 1 of dest. So that's where we get a copy of source into dest. Okay, so now what I need to do first is I need to declare my variable, which I'm going to use for the looping. So here I will just say for I, I'm beginning from 0, right? For I equals to 0. So what should be the condition? src, since I'm looping over source now, right? I'm looping over source because it is the element of source I want to store the dest. So I need to loop over source first, just like what I explained here. So src not equals to index I, not equals to the terminating null byte, right? Then what? Then I plus plus. So what do we need to do here? So inside this for loop, I can now say what? Dest index I is equals to what? Is equals to source index I. So that's also what I explained here. Whatever is in source at that index, store it into dest at that same index. Index 0 of dest of source, the element that is in index 0 of dest should be, sorry, the character at index 0 of source should be stored in index 0 of dest. The character at index 10 of source should be stored at index 10 of dest. Okay, that's why I did something like this. So dest index I is equals to source index I. So whatever is in source, let's say for the first iteration I is 0. So whatever is in index 0 of source will be stored in index 0 of dest. Whatever is in index 20, assuming I is 20, whatever is in index 20 of source will be stored in index 20 of dest. Do you get it? So now, if I should say return here, return what? Because we are told to return a pointer to the dest. So I will just simply say dest here, because this has already been declared here as a what? As a pointer. So there is no need for me to declare it again. So I just need to return it. But when you do like this, it's not going to work. It will work actually, but the checker will fail because the checker said including the terminating null byte. And when we are doing our loop here, as you can see, our loop is terminating when it encounters a terminating null byte. So terminating null byte is not included in the copying here. So all I need to do here is after everything finish, after the loop, I need to what? I need to say dest at index I is now what? Is now equals to the terminating null byte. So what happened here is this. The moment it reaches, I reaches a certain value and the element at that index of I is equals to terminating null byte, you know that it will not execute this part, right? Because this condition is false, right? Isn't it? It will not execute this part. Instead, it will jump into this. So whatever the last value of I is, right, I want to store the terminating null byte at that position. So with this, I have what? Appended a terminating null byte after the what? The strings. After the character stored in what? In dest. So now this is the last element in dest, okay, which is the terminating null byte. So with this, the checker will check. Okay, so now let's test Betty first. So Betty 9. Okay, it says one, no description for return value. Did I not? Okay, yeah, I did not explain the return. Okay, so here I need to tell Betty that return, let me just say dest, just return dest. So I think now it's okay. All right, so let's create the test file, which is 9min.c. all right, so let's copy, so paste. So here I need to say hash I. Hash. Alright, so I will say compile, right? I need to compile now, so gcc, the compilation command. Good. So let's run the compiled file, which is this. So as you can see, we got the exact output here. So when you look at this, this is the function call, right? S1 was passed to the function. This is the destination where you are copying the content to, and this is what you are trying to copy, right? First solve the problem, then write the code. So here it is printed. As you can see, we are getting this. So the next thing is what? When the function is called again with ptr, which is this, the function call, right? ptr is storing the function call. Okay, so when ptr is called, we are expecting to get a copy of it. So that's why we're having this printed here. Okay, so this is just how you can be able to loop over strings and copy the element from one pointer or from one variable to another variable. So don't forget to add, commit, and push to your GitHub repository. So we are ending the session here. Thank you very much. Till meet in our next session.